Hello viewers, welcome to this lesson 1 of algebra or mathematics for the upper basic level. And on our lesson 1, we'll be looking at algebra, which is a very broad term. But before we even start doing that, it would be a good idea to have a pen and paper by your side, because this is mathematics, so we may be working some steps along together. So have a pen and paper by your side, and we see what we get to. Like I said, we are looking at algebra for this lesson 1. And under algebra, we are looking at the algebraic processes and linear equations. Now, like I said, it's a very broad term, algebra. So we're only looking at 3 aspects for this lesson. That is the vocabulary involved. Then we look at translating between words and expressions. And then we'll be looking at how to evaluate expressions. Those are the 3 areas we are covering for this particular lesson. Now, let's start with the vocabulary. Now, the vocabulary are the words or terms that you will come across as we are teaching this topic. The first one we have there is the constant. Now, what is a constant? A constant is a fixed value, a number on its own whose value does not change. A constant may either be positive or negative. Now, here's an example. 4x plus 2. Now, if we look at that and going by our definition that a constant is a number on its own, you can clearly see here that the only number standing on its own here is the 2. What if I had, let's say, 2x minus 3? Again, going by our definition, it should be the number that stands alone. But again, remember, we said a constant may either be positive or negative. In this case here, our constant is all of this. That's a negative 3. So we can't say the constant here is 3. Instead, it is negative 3. On the first example, we could have written only 2 because it is a positive 2. And unless you are dealing with integers, you can always drop the positive sign. But the negative sign, we cannot drop. So in this case here, the constant is negative 3. Now another example could be, let's say we have 7p plus 7. Or let's make it a bit different and avoid 2 7s. Let's say we have 7p plus 9. Now there, going by our definition again, the only number that stands alone here is 9. And the 9 is positive 9, so we can write just 9 because it's a positive. And like I said, if it's not integers, we are allowed to drop the positive sign if we want to. So here the constant would be 9. Now, it does not mean that the constant always comes last. Because I could have given you something like this. 8 minus 3p. And there, clearly, we can see that the number standing alone is the 8. So in this case here, our constant is the 8. So the constant does not have to come last all the time. It could be at front or at the back. Now, the second vocabulary we are going to be coming across is the variable. Now, a variable is any letter or symbol that represents a changeable or unknown value. Let's make it easy. The variable simply is the letter in the expression. So if we look at the first example we have here, 4x plus 2. Said the variable is the letter. And in that one, the only letter you have there is x. So x represents the variable here. let's look at another example. I may be given 3y plus, let's say, 10. Now, what is the variable in that? We know the variable is the letter, so obviously, the variable we have here is the y, because that is the letter. And if I have something like 25 minus, let's say, 2p, still, in all of that, the only letter you have there is the p. So the p, in that case, becomes your variable. So the variable is just the letter. That should be easy to remember. Then we move on to our next vocabulary, and that's the coefficient. A coefficient is the number multiplied by the variable. It is located in front of the variable. So we say this number that is being multiplied by the variable, and it is located in front of the variable, which is very important. We'll come back to that. But in this example here, where you have 4x plus 2, if you look at that, the variable is x, and the number that is being multiplied by that x there is 4. So therefore, in this case, 4 becomes your coefficient. Likewise, if I have 6y minus 9. Now, anytime you want to really determine the coefficient, always look for the variable. Once you are able to locate the variable, then the coefficient is just the number that is being multiplied by that variable. And it is always located in front of the variable. Now, that is important that we say it is located in front of the variable. In maths, we don't tend to write y6. Although I know you may say, okay, y6 is y times 6, but then the coefficient should always be in front of the variable. So instead of writing y6, you have to write 6y. So we know the number in front of the variable y here is our coefficient. This is very, very important to note that if a variable contains no visible coefficient, the coefficient is actually 1. What this is simply saying is that actually every variable has a coefficient. So if you can't see any coefficient in front of the variable, we know that 1 is actually there. Like for example, x plus 7 is exactly the same as 1x plus 7. So although the 1 was not visible here, but we know it is there. So the coefficient of x in this case is actually 1. Likewise, negative x plus 7 is the same as negative 1x plus 7. So again, although we don't see the 1 there, but we know it is there. So if I do have 2 plus y, now I know that there is no number visible here, but actually I know the 1 is actually there. So the coefficient of y in that case is a 1. So we can simply agree that every variable has a coefficient. It's either visible or not visible. If it is not visible, it is 1. Now, let's just look at a few questions to see if we are following what we have been saying. Now, here we have an example. It says, in 2x minus 12, the variable is x. Now, based on what we have said previously, will we agree that in that expression there, the variable is x? And obviously, if we refer back where we said the variable is just the letter, so definitely it is true that in this case, the variable is x. Another one would be 6y plus 20. again, is the variable there y? I can hear you say yes, because that is true. The variable here is y. Here we have another one. In 3x plus 4, the coefficient is 3. And looking at that and going by what we have said before, that the coefficient is the number being multiplied by the variable, and it is always in front of the variable. So in this case here, clearly, 3 is the coefficient. So that is also a true statement. Now, what is the constant in 7x minus 3? Now, this is one area we need to be careful with. We are looking for the constant. We know the constant is the number that stands alone. That we know. But what we can easily miss is that the constant here is actually all of this. So 3 would not be correct. Instead, the correct answer to this would be the negative 3. Now, what is the coefficient in negative x plus 3? Do we have a coefficient there, or don't we have any coefficient here? And we have already established that actually every variable has a coefficient. We have established that already. So definitely this x has a coefficient. Since it is not visible, we have agreed that you can always put there 1. So this is negative 1x plus 3, which means our coefficient here is actually negative 1. Now, let's look at this situation here. In 2x minus 12, the variable is x. Is that true or false? Now, going by our definitions before, we have agreed that the variable is simply the letter. And in this case here, x is definitely the letter. So this statement is a true statement. Okay? Then let's look at another situation. In whereas we have in 6y plus 20, the variable is y. Again, is that a true statement or not a true statement? And obviously, the variable being the letter, so this makes this one as a true statement as well, that y is definitely the variable in this situation. In 3x plus 4, the coefficient is 3. Again, if you are just to refer back to what we said previously, that the coefficient is the number being multiplied by the variable, and also it is the number located in front of the variable. So obviously then, it's true that 3 is the coefficient in this case as well. That's a true statement. Now, next we have, what is the constant in 7x minus 3? Now, this is something you have to be careful of, because you may be tempted to just take the 3 as your constant. But actually, the constant here is all of this, which makes negative 3 here as the correct answer. Because remember, we have said that if it was a positive, it is okay that we can drop the positive, but we can't drop a negative. So in this case here, negative 3 would be the correct answer, and not 3, which is very tempting. Now, what is the coefficient in negative x plus 3? Remember, I did say that really to locate the coefficient, focus on the variable. Once you are able to locate the variable, then we know that the number in front of the variable will be your coefficient. But in this case, you look in front of the variable, and there is no number visible there. But we have said previously before, if no number is visible in front of the variable, we know that 1 is actually there. So negative x is negative 1x plus 3. So there is a coefficient there. And clearly, it is the negative 1. Now here's a such statement. X has a coefficient. Is that true or false? I don't think there's any debate here. That previously we have said that every variable has a coefficient. So this makes this absolutely true. So we move along to algebraic expressions. What is an algebraic expression? An algebraic expression contains numbers, variables, and at least one operation. Now, 3 key components there. You have numbers. So an algebraic expression must contain numbers. It must contain variables. And at least one operation. We know the operations are just for a number, either addition, subtraction, the multiplication, and the division. So it must contain at least one of those, meaning it can contain more than one. You may have 2 operations in the same expression, but there must at least be one. You can't have an expression with no operation. You can have more than one. Now, here's an example. 4x plus 2 is an algebraic expression. Now, let's look at that carefully and see if it qualifies based on what we have said before. Does it have all the characteristics? Does it have numbers? Yes, we have 2 numbers there. So that is okay. Is there any variable there? Yes, there's a variable there. There's an x there. There's also. Do we have any operation there? Actually, we do. But how many operations are even here? We have more than one in this same expression here. We have 2 of them here, because we can clearly all see the addition. That's an operation. But also what we know is that 4x, if you have to expand that, you get 4 times x. So that's a multiplication right there. So in this one expression, you have 2 operations. You have an addition, likewise you have a multiplication. So it contains numbers, it contains a variable, and it contains operations. So it is an expression. Now think of another one. Let's say you have 3q minus 7. Does that qualify as an expression? Let's investigate. Do we have any numbers there? Yes, we do. Do we have any variable there? Yes, there's a variable. Do we have any operation there? Yes, there is a subtraction, and likewise there's a multiplication between the 3 and the q. So this will definitely pass or qualify as an expression. How about this? X plus 1. Do we have any numbers there? Yes, there are 2 numbers. One is here, one is also here. So that's covered. Any variable? Yes. Any operation? Yes, there's an addition here. Now, what if you come across a number like 23? Now, do we qualify this as an expression? Does it have all the qualities, that numbers, variables, and an operation? It's tempting to say no, there's no variable here. So it's not an expression. So now we move on to what an equation is. We've just discussed that an expression contains numbers, variables, and at least an operation. That is an expression. Now we move on to what an equation is. An equation is two expressions balanced with an equal sign. It's two expressions balanced with an equal sign. Now, example here, we have 4x plus 2 equals 14. Now, that is an equation. Why? Because you have an expression on the left-hand side, and you have an expression on the right-hand side. And then you have the equal sign there. So that qualifies this as an equation. Now, I'm sure you'll be asking in your head, but how comes 14 is an expression? We have just said that an expression must contain numbers, variables, and at least an operation. And clearly, there is no variable visible in 14. But let's recall our indices. 14 is the same as writing 14x to the power 0. Now, if you further simplify this, you will get to 14 times x to the power 0. Now, you have a number there, you have a variable as well, and also you have an operation. So it is clearly now an expression. Now, if you simplify this, won't you get 14 times, we know from our indices that x to the power 0 is 1. And if you multiply 14 by 1, you get back to your 14. So that 14 is clearly an expression. So this qualifies as an equation, therefore. Now that we have looked at what an expression is and also what an equation is, what is the difference, therefore, between an expression and an equation? Let's see what happens here. We have said that an expression contains numbers, variables, and operations. That's what makes up an expression. An equation contains numbers just like the expression, variable just like the expression, operation just like the expression, but an equal sign which is absent in the expression. So therefore, we can easily say that the only difference between an expression and an equation is the equal sign. That is their only difference. Right, now that we have built up our vocabulary, I know it's mathematics, and so far we have not done any calculations, but don't worry, we'll get there. Now we move on to translating between words and expressions. Now, how do you write a mathematical sentence into an expression? Now, first, let's start with addition. Let's try to list all the words that we know indicate addition. Now, the easiest we can all remember is plus. We know plus is addition. And we can also take add. Add is definitely addition, just as it is in the name. Again, we can think of something like more than. More than also indicates addition. Increase also indicates an addition. Now, there could be a few more words than this. Looking at here, you can see the sum is addition. The total is addition. Like we said before, add, plus, increase by, more than, all together. We come across all this all the time. They all indicate addition. Now, we also do the same thing for subtraction. What are the words that indicate subtraction? Now, the easiest word that springs to mind That's minus. We all know minus is subtraction. Or we say subtract. Now, another word that could also indicate subtraction is difference. Difference simply means subtraction. Less. Less is subtraction. Likewise, less than. Less than also indicates a subtraction. We do have quite a few more words. I'm sure you know them. Now let's see. This helps. We have minus, difference, take away. Yeah, we use that a lot. Take away. Less than, subtract, decrease by, less, fewer than, and then subtracted from. All this indicates a subtraction. How about multiplication? What's the first word that comes to your mind? Times. It's multiplication. Then, product is multiplication. We can think of twice. It's 2 times. So it indicates a multiplication. What of double? They all indicate multiplication, and there could be a few more words that you know. Product, times, of, twice, double, and multiplied by. All this indicates a multiplication. Now on to division. Now what are the words that you can think of when it comes to division? You could say divide. It's easy. We see quotient. Quotient is division. Half, and quite a few other words could be available, like, divided by, quotient of, half, fractions, divisible by, divisibility, all centered around division. All this indicate division. Right, now here is something very important here. Be aware of the difference between less and less than. Less and less than. For example, 8 less 3 and 3 less than 8 are equivalent expressions. So what is the difference in wording? If you are going to translate 8 less 3, you will have 8 minus 3. But if you also translate 3 less than 8, you still get to 8 minus 3. Now this is key. When you see less than, you need to switch the order of the numbers. Simply meaning, the first number becomes your second number, and the second number becomes your first number. That is what you do when you see less than. So we say, as a rule of thumb, if you see the words than or from, they do the same thing. It means you have to reverse the order of the 2 items on either side of the word. So if I have, for example here, 8 less than B, because I have less than there, I know I have to switch the order of the items. The second becomes the first, and the first becomes the second. So 8 less than B becomes B minus 8. Likewise, 3 more than X. Again, you have the word than is there. So I need to switch the 2 items. The first becomes the second, and the second becomes the first. So 3 more than X translates to X plus 3. then x less than 2 also following the same pattern will lead you to 2 minus x. Now, the many ways to represent multiplication. There are many ways we can represent multiplication. If I want to write 3 times a, now there are multiple ways I can write that. I could just put the 3 in bracket, the a in brackets, and that there represents 3 times a. If I want, I can write the 3 and only enclose the a in bracket. Again, it indicates 3 times a. Or 3 with a dot between the 3 and the a. Still, that dot there between the 3 and the a is actually indicating a multiplication. Although at our level, we don't tend to use it. But it is there. It's a multiplication as well. Or simply write 3a. It's all the same. 3a is 3 times a. So all these are ways I can write 3 times a. But the preferred representation is 3a. We prefer that you write 3a. But it does not mean that if you write the other ones, it's wrong. But we prefer to write 3a. Right? Now, when a variable is being multiplied by a number, the number, that's the coefficient. Remember previously we have said that the number being multiplied by the variable is the coefficient. So if the coefficient, when a variable is being multiplied by a number, the coefficient is always written in front of the variable. And again, we have mentioned this previously, that it is not okay to write a3, that the coefficient should come in front. So we say the following are not allowed. 3 times a, the multiplication sign looks like another variable. Now that is important. You write 3 times a like that, and your multiplication looks like an x. Now somebody marking this could mistake this for 3xa. So make sure that your variable do not resemble an operation to avoid confusion. Likewise, a3, this also is not allowed. The number is always written in front of the variable. So you don't put the variable in front of the number. It's the number, then the variable. These are things that we should be careful with when we are working. Now, representation of division. Now, we have looked at the different ways you can represent multiplication. Now, on to division. If I want to write b divided by 12, that could be written as this. Just b divided by 12. Or somebody can just say b slash 12 is division. Or b over 12. Now actually this and this are pretty much the same. And that over there we know it represents a division. So all three are ways that people can write division. Now when choosing a variable, there are some that are often avoided. Now here are some examples. L, the small l. I, the small t. The small o and the capital O. The small s and the capital S. Now why do we avoid this? Why are we advised to avoid using this as our variables? It is best to avoid using letters that might be confused for numbers or operations. And some of these can easily be confused for a number. Imagine you want to write 1L, and you write 1L. You are taking that as your L, but looks like 1, so we avoid that. Let's say somebody wants, I want to write 5O, and I go ahead and write my 5O. Somebody can definitely read this as a 50. So this is why these you are advised to avoid using them as your variable, because they can easily be confused as numbers or operations. Because even this t, small t, some of us write small t as that. Or let's say this. Still, looks like an addition. So that is why we are advised to avoid this. In the case above, you can convert this for 1, and addition is 0 and a 5. So in as much as possible, we avoid using these as our variables. Okay. Now, let's do some practice here. We're going to translate these into expressions. We have 3 times j. Now, we want to write this as an expression. Now, here we have our numbers and operations. Now, let's see if we can write this. We have 3. Okay. Now, what can represent a multiplication there? Because time is multiplication. So this can represent a multiplication. There you go. And we are multiplying by j, and there's a j available there. So, yeah, that would represent 3 times j. 8 divided by j, if I just fast track it a bit, we get 8. The division is there. And, of course, the same j. So that gives us 8 divided by j. Now, here you have to be careful here. 7 less than, j less than 7, I mean to say. J less than 7. Now, less than. Recall, we said if you see less than or actually the word than, it means we need to switch the 2 terms. That the second becomes the first and the first becomes the second. So j less than 7 actually will lead to having 7 coming first instead of second. It's a subtraction. And then the j will follow. There you go. And the same thing works with 5 more than j. Again, the than is there, so we need to switch the order. So that's going to give you j. We have known now that more than indicates an addition. So we have plus, and then the 5 can easily come in. And quickly, for less than j would be j. Less is a subtraction, and then you get your 4. Yeah, that's quickly fixed. Now, write the expression for each statement. Now, here we have an expression. The sum of 23 and m. Now, what is the key word here? The key word here is sum. What does sum indicate? Sum simply indicates an addition. So we know that we are adding here. So the sum of 23, I'll have 23, is an addition plus. And then you have your m. So therefore, the sum of 23 and m is just 23 plus m. That, yeah. And then, moving on, 24 less than d. 24 less than d. Be careful, less than. That indicates we need to switch the order of the 2 terms because of the less than. The second is going to come first, so the second is d. It comes first, and we're subtracting, minus, and then the first is 24, and that works out fine. And that can be confirmed with that, and there we go. Now, write the expression for each statement. Now, remember, sometimes you need to use the parentheses for a quantity. Now, the parentheses are the brackets, open and close. We call them the parentheses. So sometimes we need to use them. Now, here's an example. 4 times the difference of 8 and j. Now, looking through that, what are the key terms here? Times. Times we know indicates multiplication. What else is key here? Difference. Difference indicates a subtraction. So we know here we are simply multiplying this 4 by the difference of 8 and j. Now that's all we are doing. We are multiplying the 4 by the difference of 8 and j. Now, if you write difference of 8 and j, we will have 8. That's not 8. We will have 8 minus j. Now, that covers the difference of 8 and j. Now, you are multiplying all of this by the 4. That is why you now require the brackets or the parentheses. And then you get your 4 here. So that is how you write 4 times the difference of 8 and j. There you go. So the parentheses can be very, very useful. Now, how about this other one? The product of 7 and w divided by 12. The product indicating a multiplication divided by, the name says it all, you are dividing. Okay? So we have the product of 7 and w being divided by 12. So again, you are dividing all of this by 12. Okay? Now, the product of 7 and w could be 7 times w. Now, we're dividing this by 12. We could say all over 12. But of course, we do know that 7 times w will simplify to 7w all over 12. But if somebody writes 7w 12, you are basically doing the same thing because they all indicate a division. And also, somebody else can decide to write the same expression there as 7w divided by 12. All three are saying the same thing, and they're all correct to do. Now, the square of the sum of 6 and p. The square of the sum of 6 and p. Now, the square indicates you are raising to power 2. And then the sum there is you are adding. So what all you are doing here is you are taking the sum of 6 and p and then raising all that to power 2. So in the end you have 6 plus p. We need to use the parentheses and then you square that. So that is all you have been required to do here. The sum of 6 and p all squared. Yeah. Now, let's see if we can answer this ourselves. How do we write the quotient of 200 and the quantity of p times 7? Now, how do you write this? What are the key terms here? Quotient. indicates division. What else? We have times, indicates multiplication. So here we are simply dividing 200 by the product of 7 times p, which we can write as 200 over p times 7. That simplifies to 200 over 7p, which someone can decide to write as this as 200 divided by 7p, which is okay, or still 200 7p. Now, these are all three ways someone can write same thing, but they're all correct. Now, look at this one now. 35 multiplied by the quantity r less 45. I know we have come across less than, but let's note that this is just less. It's different from less than. But again, what are the key terms here? Multiplied by, indicating times, multiplication, right? Less is still subtraction, just like less than. But where are they different? In less than, you switch the terms. But in only less, you don't switch the terms. They maintain their positions. So if I'm going to write r less 45, I'll simply write that as r minus 45. That will give me r less 45. And then I'm multiplying all of that by 35. So again, I must make use of the parentheses, the brackets, 35. And that should be the correct answer there. I don't need to show the answer. No. Now, how about this? Fatu had 5 jelly beans for each of 4 friends. Fatu had 5 jelly beans for each of 4 friends. Now, what is the key term here? Fatu had 5 jelly beans for each of. I will take off as key here. Of, if you just refer back to your order of operations, O is of and of indicates a multiplication. So Fatu had 5 jelly beans, so you get 5 for each of the 4 friends. That is going to give you times 4, because he is giving 5 jelly beans to each of the friends. So you're giving 5, 5, 5, 5 to 4 friends. So that gives you 5 times 4. So that will be the expression for that. Now here is a tricky one. If n plus 4 represents an odd integer, the next larger odd integer is represented by what? Now, let's focus on odd numbers a bit. What's the first odd number you can think of? 1 is odd. The next odd number after 1 would be 3. The next odd number after 3 would be 5. And then we will have a 7. Now, these are all consecutive odd numbers. Now, what is the pattern there? From 1 to 3, what did he do? Plus 2. Now, from 3 to 5, what did he do? Plus 2. And then, from 5 to 7, you still continue doing the same plus 2. In essence, to move from one odd number to the next, you simply add 2. So therefore, if our odd number in this case here is n plus 4, all of this represents one odd number. If you want to get the next larger odd number, going by what we have been doing here, we will simply also just add 2 here. Of course, the 4 and 2 can be added, and that will simplify to n plus 6. And that would be our answer. What is a less than 7? Now, a less than 7. I'll go back. Wait, I'm not going to.
Still 11. You are calling us 7 when it is 27.
Oh, I called 7. Oh. Right. So we look at a less than 27. Now, again, it is less than, which indicates that we need to switch our 2 terms. The second is first, less is actually subtraction, and then the first is now going to be the second. So you have a less than 27 being 27 minus a. So we look at this other one here. It says if h represents a number, which equations is a correct translation of 60 more than 9 times a number is 375. Now the key terms here, more than, times, and then it says a number. And we know our number in this case is h. So that means 9 times h. So if we put down the terms, we have 60, more than we know is addition, 9 times h, we know is 9h. So now all we have to do is to arrange this. And we know because it is more than, we need to switch the order. So therefore, by the way, is just equal. Okay? That is equal to 375. So if you now arrange this, the second comes first. So the 9h is first. Then you have the plus 60, and that is equal to 375. So in the end, that is the equation we end up with, which would be that. With that, we come to the end of today's lesson. We have learned something from it, and we will continue next time we meet again. In the meantime, stay safe. We know the problem we are facing right now. Please follow the directives from our health workers. Let's wash our hands regularly. Stay at home as much as possible. And then let's practice social distancing. This too shall pass. Thank you.